Let's imagine we have a class named turret, which should deal damage to the nearest enemy within a specified range. Luckily, we have a function called getNearestEnemy that returns an enemy if one exists. Inside we go through all the enemies in a for each loop and calculate the distance to the turret. We check if they are in the turret's range, and if an enemy is the current closest one, we set a variable to its distance. If another one gets closer afterwards, it becomes the new closest enemy and updates the minimum distance variable. We can make it look a bit cleaner by nesting the if statements and getting rid of the range check by initializing min distance to the range itself. This approach works and will find the closest enemy, but it's hard to read and stretches over 16 lines of code. What if I told you that we could get away with a quarter of that? 4 lines. The magic solution is LINQ. It was added in C# version 3 and stands for Language Integrated Query. To show you, I think it's best to just look at the 4-line solution. Beautiful, isn't it? So let's write it together. We take our enemy list and select only the ones that are in range by using the .where method. The syntax is a bit hard to get into at first, with the strange lambda arrow, which by the way only got integrated into the language because of LINQ. But once you get used to the syntax, you'll be writing queries 10 times faster. We could already use this to get all the enemies in range for an area attack. If you've played a balloons game, this could be useful for something like the track shooter. But if we want the single closest one, we can use the .orderBy method to sort them by the distance to the turret. This sorts them ascending by default. If you want the one furthest away, you can use the .orderBy descending method instead. Since this gives us a list of elements, if we want the closest one, we could use the .toList and grab the index 0. But a safer and more convenient method is .first or default. It does exactly the same thing and returns null if the list is empty or if there are no enemies in range. So make sure to implement null checks when accessing an element. We can also swap out the .orderBy method by .minBy. Because in this use case, we don't actually need to sort the whole list, we just want to get the closest element. However, for such a small list, I still prefer the readability of the .orderBy method, and the difference in performance is minor. I think the syntax looks so much better than using loops, and it's way more fun to write. We will talk about the drawbacks later, but first let me show you a few more useful LINQ methods. Use .take3 to get the 3 closest enemies. Use .any to return a bool if there are enemies within range. It can also take a lambda expression to check if at least one element fulfills the condition. Use .all to check if all elements fulfill a condition. Use .select to extract a specific property like getting a list of health values instead of a whole enemy object. Use .sum, .min and .max, which are self-explanatory and work on numeric properties. Use .groupBy to group elements by a property, which works especially well for enums. Or use .distinct to remove duplicate objects. This wasn't the only great thing about LINQ. If you've ever used SQL, you'll feel right at home with SQL-style LINQ. If you wrap the LINQ expression in parentheses, you can write SQL-like queries in C# using from, where, orderBy and select keywords. We can rewrite our method using the SQL syntax. And we can even use the let keyword to store the distance calculation in a variable, so we don't calculate it twice, making the code both more performant and readable. Speaking of performance, this is also the biggest problem with LINQ. Instead of using simple methods, LINQ relies on delegates and allocations under the hood, which puts pressure on the garbage collector. This can decrease your game's performance if used too often in the update loop or on lists with millions of elements. There's always a trade-off between readability, development speed and performance, and we need to find a balance. Personally, I can live with a couple of milliseconds of runtime overhead to gain the readability and maintainability of clean code. If you really have a CPU-heavy game or need highly performant LINQ expressions, there's a package called ZLINQ, which shares the exact same syntax and acts as a drop-in replacement for standard system.LINQ. You can install it via .NET add package ZLINQ in a standard C# project or via the Unity package manager. Then for every query, we just add .asValueEnumerable as the first method in the chain, and it will automatically run with 0 heap allocation. Just keep in mind, this requires newer Unity versions. To wrap things up, thank you so much for watching. I hope you enjoyed the video and found it helpful. Also, I'm sorry I haven't posted in such a long time. I just lacked the motivation to make another video in a while. Either way, thank you so much. Please like and subscribe, and I wish you a great day.